Welcome to our class in coordinate geometry. Today we look at perpendicular lines. So two lines, line 1 and line 2, are perpendicular to each other if they meet at a right angle, or at the point of intersection they meet at a 90-degree angle. So if they are perpendicular to each other, then multiplying their respective gradients will give us -1. So find the gradient of a line that is perpendicular to the lines given by each of the following equations. So for A, our solutions. So in A, our M1 is equal to 4. So if we want to find a line perpendicular to this line, then it means multiplying M1 times M2 should give us -1. Our M1 is 4, so we're going to have 4 times M2, which is equal to -1. Dividing throughout by 4 will give us that M2 is equal to -1/4. So this is the gradient of a line that is perpendicular to the line given in A. Now notice that our M1, our gradient is 4. If we're going to write this as a fraction, it's as good as having 4/1. Our M2, which we have calculated, is -1/4. What we have here is 4/1. This one is just the reciprocal of the first gradient. So the denominator becomes the numerator becomes the denominator, or you just swap the numbers. You have 1/4. This one was positive and this one is negative. Meaning, if what you have in if you get the gradient M1, to get the gradient M2, just get the reciprocal of M1, then give it the opposite sign to the first gradient that you have. If this one was negative, this one would be positive. In this case, we have a positive. Our second gradient is the opposite sign we have in M1, which is negative. Having said that, let's try working out B without the calculations. So if we simplify B, or to make it B in the standard form of a linear equation, which is mx plus c, you'll find that our y is equal to minus 3/4 plus 3. That's this equation in that standard form. There is x here, minus 3/4x. So meaning our M1 is giving us -3/4. Therefore, our M2, we swap the numbers. We're going to have 4 on top, then 3 down. This one is negative. The other one, which is M2, has to be the opposite sign, which is positive. So our M2 is 4/3. You can try multiplying these two. They'll really give you -1. So for our final example, I got it from a 2016 past paper and it was awarded 3 marks. So we have the line y plus x/7 is equal to 1. We want to find the equation of the line that is perpendicular to this line and passing through -4,4. So let's first of all make y the subject of the formula so that this line can look more like be in the general form of a linear equation, which is y is equal to mx plus c. So we're going to have y remaining this side. We bring the x/7 on the other side. We have -1/7x plus 1. We have it now in standard form. So our gradient from that line M1 is -1/7, meaning our M2 is a reciprocal of this one, which is 7, and the opposite sign to this one, which is positive. And the second line is passing through -4,4. So using our 1-point formula, we'll get the equation of this second line with the gradient 7 and passing through this point. So we're going to have y minus our y1, which is 4, is equal to 7x minus our x1, which is -4. Simplifying that one, we have y minus 4 is equal to 7x plus 28. Negative, it will be positive. 4 times 7, it will be 28. So you have y is equal to 7x plus 28. The 4 comes this side, you have now becomes positive, and the equation therefore is 7x plus 32. So this line is perpendicular to the line given in the equation. I have a task for you. So you try working out this question and show that your answer comes to y is equal to minus 2 over 3x minus 1. Thank you.